Okay, so continuing on with our stoichiometry calculations. Now we just finished up with limiting reactants, and we're going to, or with percent yields. Now we're going to take a look at limiting reactants. Okay, so in a limiting reactant problem, one of the reactants limits the amount of product that you can make. Alright, so let's say to make us some more that we need 1 marshmallow, we need 2 squares of chocolate, and then we need 1 graham cracker. And then we break that graham cracker in half, so we have a top and a bottom. So let's say that we go to our cupboard and I find out that I have 30 marshmallows. And I come up with that I have 16 squares of chocolate, and that I have a pack, and the pack has 60 crackers. So I would think, since I had 60 crackers, that I could make 60 s'mores. But that's not the case, because when I look at my chocolate, I only have 16 squares. So if I only have 16 squares of chocolate and I need 2 for each s'more, then I could actually only make 8 s'mores, even though I have 60 crackers and 30 marshmallows. So my chocolate is limiting how much I can make. So we're going to take that same concept and we're going to apply it to a reaction. Alright, and lucky for us, they gave me a balanced equation. If it wasn't, I would have to balance it. Alright, and in this one, they've given me that I have 752.3 grams of this first term. And they've also told me that I have 837.1 grams of the iron. And they told me that I had an excess of this stuff. Alright, so how I'm going to tell that I have a limiting reactant problem is they have given me amounts of 2 of the reactants. Now, with our percent yield, they gave me the amount of one of the reactants, and then they gave me the actual yield of one of the products. But in this case, they've given me amounts of 2 of the reactants, so that clues me in that this is a limiting reactant. And in this problem, they want me to figure out how many grams of this product I can make. So a limiting reactant problem basically involves you doing your stoichiometry calculation twice. So we're going to start out with our 752.3 grams of my C6H5NO2, and I'm going to go through and do, since I want grams, I'm going to have to do those 3 steps. So I first am going to have to calculate my molar mass. Okay, now I didn't write it out this time, but I took 6 carbons, 5 hydrogens, 1 nitrogen, and 2 oxygens from the periodic table, and I added up their masses. then my next step is going to be doing a mole ratio, and I'm trying to find this product. So what I want is 4 of this C6H5NO3 or NH2, and I have 4 of the C6H5NO2. And then last, I do the molar mass of this one. So 1 mole of the C6H5NH3. So now I'm going to need that molar mass. H2. Okay, I want to double check that. Okay, I got the same number. H2. Okay, multiply everything on the top and divide by everything on the bottom. Alright, I had 4 significant figures. One's got 6. That doesn't count because those are exact. So least amount's 4. So 569.1. Alright, now I have to do the same 3 steps, but this time I have to use my iron. So nothing new yet. Alright, and 55.847 grams in 1 mole. That's from the periodic table. And then my mole ratio, I'm going to be doing Fe, which has 9, to the 4 of my product. So 4C6H5H2 for every 9. And then I already found the molar mass of that product, 93.128 grams. Now, when I'm doing those molar masses, it's always for 1 mole. So don't try to put this times 4 for 4 moles. You don't ever want to use these coefficients for anything else than that mole ratio. Okay, so I'm going to take and multiply everything on the top. And then divide by what's on the bottom. And again, 4 significant figures. And I'm just going to double check that number. So far we haven't done anything new. These are the same steps that we've been doing so far. But this time now I have made two amounts. Well, remember, one of these is limiting how much I can make. So the one that limits the amount I can make is this smaller number. This is the most that I can make. And that came from this C6H5NO2. This is my limiting reactant because it is the reactant that is making the smallest amount. And the maximum yield that I can make is 569.1 grams. This is the maximum mass that I can make. So even though according to my iron I could make this much, I really can't because I don't have enough of this reactant. So this reactant produces that amount. So out of those two calculations, I pick the smallest one. That's the amount that I can actually make. And then whichever one produced that smallest amount, whatever reactant that was, that is your limiting reactant. And that's all that you can make. So this part, this is nothing new. Our only new step for this kind of problem is I had to pick the smallest one to tell me the amount that I can make.